Alright, so this video is going to cover this 2011 free response question number 3, and it's the fuel tank one. So it says a fuel depot has a number of fuel tanks arranged in a line and a robot that moves a filling mechanism back and forth along the line so that the tanks can be filled. A fuel tank is specified by the fuel tank interface below. Okay, so you got a fuel tank, it's an interface, and all it knows how to do is to get the fuel level. All right, so your fuel level, so each of these would represent a fuel tank, and this is the tank index. All right, so the only thing that the fuel tanks know how to do is return the fuel level. So this would return 80, this would return 70, 20, 45. Okay. Now it looks like there's a robot here that's running back and forth filling up fuel tanks. So it says a fuel depot keeps track of the fuel tanks and the robot. The following figure represents the tanks and the robot in a fuel depot. The robot indicated by the arrow is currently at index position 2 and is facing to the right. Okay. So the robot is also interface, and it looks like the robot knows how to get its index. It knows if it's facing right here it's facing right, so that would return true, but if it was facing left it would return false. If you get to the end here, you probably have to turn left, so you have to change the direction and then go forward. Move forward, and the number of locations it's going to move forward. Okay, not bad. Alright, a fuel depot is represented by a fuel depot class. So the fuel depot will implement the fuel robot, and its object will be called filler. And we'll have a list of fuel tanks represented by the tank. So this is going to be an array list. So remember, with an array list, we're probably going to have to use .get in order to get the current index position. Sorry. So I put all this in here, and I'll be going up and down here instead of switching back and forth. But there's our get fuel level. The robot gets the index, is facing right, changing directions, moving forward. Let's go down and keep going. It says A, write the fuel depot method next tank to fill, returns the index of the next tank to be filled. The index for the next tank to be filled is determined according to the following rules. Okay, return the index of a tank with the lowest fuel level that is less than or equal to a given threshold. If there is more than one fuel tank with the same lowest level, any of their indexes can be returned. If there are no tanks with the fuel level less than, so return the index's current robot index. So we either have to return this bullet points information or this one, which would be the current index robot. So I'm going to quickly write that. So for part A, that's right here what I'm writing. So let me think here. So the minimum, no matter what, is going to be this, whatever the robot's current index position is. That's what that's saying here. If there are no tanks, then the robot's current index position, so their current is starting off going to be the minimum index position. So I'll just say int int min minimum index is equal to, we've got a robot, where's it at, called filler. So this dot filler dot, and the robot has get current index. Okay, so that's the minimum index right there, and if there are no tanks with a fuel level less than or equal to the threshold, return the index's current, robot's current. Okay, so there's our minimum index. And I created a variable because just in my head, we're going to have to compare what index they're in. So instead of having to write that out when we're looking at this, I'm just doing that. But you could just say right here and not do this and just say, return this dot filler dot get current index right there. That would work. But again, this is a little bit cleaner for what we're going to do as well. So let's think about this. They give you the current index, but then you're going to have to basically do a loop to go through each of these and see if this one's the smallest. At the same time, return the index of tank with the lowest level fuel level that is less than or equal to a given threshold. So threshold is passed in, okay? So whatever let's say your threshold, let's look at this. So if it's 50, even though this is your current index for your robot, this wouldn't be low enough because 20 is lower than 50, 30 is lower than 50, and this 20 here. So which one is the lowest? So whatever's at index position 0 and index position 6 are the lowest fuel levels. So one of those would be returned, and it would be yeah. And so if the threshold is 15, none of them are returned, and you just stay at the current index because none of them are low enough to fill up yet. So you don't want your robot running around filling it up if it's not. Because ideally, you would have your robot programmed and it would fill up a certain amount each time. So if your threshold, like let's say your tanks hold 100 gallons and your robot only holds 50 gallons, you don't want to start filling these up at 55 gallons because 5 gallons are going to overfill the fuel and spill all over the ground. So you want to make sure that they're at a certain threshold before you start filling them all up. At least that's how it would work in my mind. If you wanted to automate this process now, I don't know if that's a good example because then you'd have to have somehow the robot getting filled up as well, and you know what I mean? So, but whatever. So, see the following. Okay, so determine. Okay, cool. So let's do this. So I'm just gonna do a loop that runs through all of them. So for int I equals 0, I is less than this dot tanks dot size, I plus plus, because isn't our, we've got our tanks right here. Tanks are the array list. So, and typically when you're doing this array list stuff, you want to use a for each loop, but we're gonna need to do something with a tank at this position, so I didn't want to use a for each loop because I'm gonna need to use the get method, and you can't use dot get with a for each loop. So so I want to check and see if my fuel level, so it would be something like this dot tanks dot get at position I dot get fuel level, because isn't that, yep, get fuel levels up here, and that's my tanks. So I get my fuel level, and if that's less than or equal to the threshold, and I think here, and what would I do? And this dot tanks dot get at position I dot get fuel level is less than. Now this is the part where typically I would have just done a for each loop right here, and it would have been nice because you do your, you know, again, we can't do this here. You would do for what would it be? Fuel tanks. What's it called? Yeah, fuel tank. Fuel for fuel tank, tank through tanks, and then you, like right here, you would do, you know, this is really nice. You do an if the tank is less than, no, tank dot get fuel level is less than or equal to threshold. See how this cleans this up? You don't have to use this dot get stuff right here. But I'm going to run into problems on this one because I need to make sure it's less than, and be this dot tanks dot get at the minimum index dot get fuel level, right? Is that, yeah, because I want to, so this is the current one where the robot is. If this is less than the minimum index level dot get fuel level, so if the current, if what's at 0 is less than the current, which in this diagram right here, you know, starting at 0, 20 is less than 80, then this is my new minimum position, okay, that I want to use. And I don't think I can do that because I can't just go, I could do tank dot get the fuel level, but then I can't do tank dot because I need to have the current one that we're on. So I can't do this for each loop right here, at least that I can think of off the top of my head. So again, I think the AP test, and I'll have examples they want you to do for each loops, but on this one, I don't think it's possible. There might be a way. I'd have to sit around and think through it, and I'm not, off just the top of my head, I can't think of it. So that's fine. So again, you're taking where you're at in position 0 right now and checking to see if it's less, the fuel level is less than the threshold. If that's true, and the fuel level is less than where you're currently at, the robot's currently at, then the minimum index is equal to I. And so 0 would get stored in here, and then it would go through the rest. Now, this one wouldn't be less than I, which would be at that, so you would just return 0. So again, this one's pretty easy. Now, there's a lot of parts here that you're putting. The hard part about this is they've got the different object, or the different classes, basically. You got the interfaces, you got the fuel. So you're having a fuel tank, which is your array list, work with a robot, which is filler right here. And then you've got the whole class FuelDepot that implements the robot and the fuel tank array list. So thinking through how to get those together isn't that bad, but you know, if this was just a normal array, you guys would know how to find the minimum, the index with the smallest element in it. That's all we're doing here. So that's pretty easy. So next up, B, write the FuelDepot method. It will move the robot to the given tank location, because the robot can only move forward. It may be necessary to change the direction. So it's facing right originally, I believe. And yeah. It will move as many spaces, but you might need to move backwards, which would be changing the direction and then move it forward. So it doesn't know how to move left or right. It just knows how to move forward, and depending on what position you need to go to, you need to turn it, change the direction. So you put you're passing in the location. Okay, the index of the location of the tank to move to. So write the FuelDepot move location that will move the robot to the given tank location. Given the robot can only move forward, it may be okay. All right, this isn't bad. All right, so right here, let's see here, so the location that we want to move to. So let's say we're at location 4, index 4, and we want to move to the location index of 1, but we're facing right. Don't we have to check to see, is this greater than this? And if it is, we would, what's it called? What does the robot know how to do? It changes direction, and then it moves forward 1, 2, 3 spots. So 4 minus 1 would give us 3, and you can move forward 3 spots. Yeah, this isn't that bad. Okay, so we would just say if this dot we want the robot's current location. So if this dot filler dot get current index, if it's greater than what's passed in the location index, and that's what I was trying to show you guys. So if this is our current index of 4, that's greater than the location index of 1, okay? So if it's greater than that, Then what do we do? So it depends on which way you're facing, but we want to if this dot filler dot is, what's it called, is what robot is facing right, then what do? We gotta change, then if it's facing right, then we need to change the direction. So this dot filler dot change direction. Okay, so we change the direction, and then we do this dot filler dot move forward, and we want to do what? This dot filler dot get current index minus the location index. Now we gotta check to see if it's less than. So let's say it's opposite that, it's less than, so we would start at 1 and we're at 4. So if this dot filler dot get current index is less than the location index, so let's say we're at 1 and it's checking out position, it's wanting to move to position 4, then we can do okay, let me think here. So if not this filler dot is face, so if it's not facing right, I screwed up there. That needs to be a change. Set change direction. So if you're on index 1 and you're not facing right, then change it so you are facing right, and then move forward 1, 2, 3, which would be the location minus. So it'd basically be this, only it'd be opposite inside it. So it'd be, you would take the location 1 and move to 4 minus the current location of 1. So right on, yeah, I think that looks good. So let me just look here. If the current location is greater, so it'd be like if the current location is 4, is that greater than 1? If it's facing right, change the direction. So that would change the direction. You move forward. The current location, which is 4 minus 1, which would be 3. If the location's less than, the location passed in, so it's at 1, and you want to go to 4, that's less than that. If it's not facing right, then change the direction and then move forward 4 minus 3, or 4 minus 1 should be 3. All right, cool. So, let's look here. This is how they would grade this. Okay. Let's see here. Determine the minimum number of elements. Determine minimum element of tanks, that is, if any. So consider the fuel levels. Let's look at this. Remember, we did this first, and then we did this. So this is kind of like, well, I don't know how to do a for loop. How many points do we get if we just do those 2 lines of code? So you'd only receive a half a point if you did nothing else than those 2 lines of code. So consider fuel levels of, so access fuel level of an element. So if you do if you do a loop and you loop it properly and you access one element, you know, that's, you know, checking, you know, is get what's at position I less than the threshold type stuff. Access at least one element of tanks in context of repetition iteration. Access every element. So this is your loop. If you do your loop properly and you access all elements, you're good. So this compare fuel levels. So again, this 1.5 points is your loop. You know, can you set up this loop properly right here? I think that's pretty easy. You just go 0 to the size of the tanks. So compare fuel levels from at least 2 elements in tanks. Implement algorithm to find the minimum. Identify tank. Object holding identified. Compares threshold. So, you know, you're getting a point. You're getting like a point for that, and you're getting another point for that, and then you get, I think, a half a point for that. Maybe that's a full point. Yeah, no. 1, 2. So yeah, these are the 2 that does these are, you know, those are the checking to see if they're less than, and then that one is where you assign it. That's your half point for assigning it. So this section of the if statement's worth 1 point. This section's worth 1 point, and this section's worth a half a point. And like I said, we did that. That was the first line we did. Well, what's this? Yeah, we did that. So the loop should be easy. You could do that. I mean, even if you really do awful on this, you should be able to do the loop, and you should be able to do what I did on the very first line. You know, that's going to give you your 2 points. If you're not able to get the algorithm or the correct answer right there, you know, at least you should be able to get 2 out of the 5 points, which again is pretty awful. But again, you just go back to my philosophy of you can miss the hard stuff, and if you get the easy stuff, you will be okay. 2 out of 5 isn't good, but it's not gonna, you know, like I said, you'll do fine on the multiple choice section of all this, I think. Okay, so let's see here. Ensure robot is pointing in the direction of the tank to be filled. Determine the filler is currently facing. Change the filler's direction. Establish the filler's direction as appropriate. Place robot at specific location. So you get 2 points for this stuff, that, and that. And you get another 2 points if you get the move to the location stuff properly. So I don't know. It's a little bit more difficult than stuff we've worked on, I think, a little bit, but not impossible. So study up on this and you should do fine, all right?